It is easier to find a matching pair of shoes or a clean t-shirt in a clean and tidy closet. Like a tidy closet, elements are organized in rows and columns on the periodic table of the elements. This makes easier for chemists to infer their physical and chemical characteristics of elements. Hi, and welcome back. In today's science video, I will talk about the periodic table.
The periodic table. In the late 1800s, a Russian chemist named Dmitry Mendeleev presented a way to organize all the known elements. While studying the physical and chemical properties of the elements, Mendeleev found that these properties repeated in predictable patterns based on an element's atomic mass. Because the pattern repeated, it was considered to be periodic. The picture shows one of Mendeleev's early periodic table charts. Mendeleev arranged elements in rows based on increasing atomic mass and in columns based on elements that share similar physical and chemical properties. In modern periodic table, the elements are arranged by increasing atomic number, not atomic mass, and by periodic changes in physical and chemical properties. Mendeleev's prediction. Mendeleev had to leave blank spaces in his periodic table. He studied the physical and chemical properties and the atomic masses of the elements surrounding all the blank spaces. From this information, he was able to predict the probable properties and the atomic masses for the missing elements that had not yet been discovered. Table 5 shows a few of Mendeleev's predicted physical and chemical properties for germanium, which he called ecasilicon. In 1913, a young English scientist named Henry J. Moseley arranged all the known elements based on increasing atomic number instead of atomic mass. The atom and the periodic table. The modern periodic table consists of boxes, each containing information such as element name, symbol, atomic number, and atomic mass. The horizontal rows of elements in the periodic table are called periods and are numbered from 1 through 7, as you can see in the picture. Then, the vertical columns in the periodic table are called groups, or also families, and they are numbered from 1 through 18. So here you can see the types of family, for example, the transition metal family, the boron family, oxygen family, and so on. Now let's talk about energy levels. In a previous lesson, we learned that atoms are made of subatomic particles called protons that have a positive charge, neutrons that have no charge, and electrons that have a negative charge. Energy levels is the distribution of electrons of an atom in different levels and sublevels of energy. The levels are numbered from 1 through 7. They divide the periodic table in 7 periods. And the sublevels are classified in these 4 letters: S, P, D, and F. And it can tell us from an element the form of the orbit of an atom and also the energy it has. Now, in these sublevels, for example, the letter S only admits 2 electrons. The letter P only admits 6 electrons. D only admits 10 electrons, and F only admits 14 electrons. Now, let's use the diagonal rule for making electronic configurations. You're going to need a piece of paper and a pencil. So, write on the left side the 7 levels of energy. And remember to work in order. So like this, from 1 through 7, and leave a space in between each number. Then we need to add the sub levels. Remember, S, P, D, and F. And we're going to follow this order. So number 1 only have one level, only S. Number 2 only have 2 levels, S, P. Number 3 only have 3 levels, S, P, and D. And from 4 until 7, they have 4 levels, S, P, D, and F. Now, get another color pencil and we are going to start tracing diagonal lines, like this one. So we're going to start up here from the letter S and down to the number 2, like this. Then the next one, and next one will start with P, S4, PS5, DPS6, DPS7. And I'm gonna stop there because usually we don't work with the other levels. Now let's practice. Let's find the electronic configuration of oxygen. If using the periodic table, you can see that oxygen has an atomic number of 8. This means it has 8 protons, which are positive, and 8 electrons that are negative. Now let's use our diagonals. So first we have the letter S, and here we have the number 1, so 1s. And remember that in the level S, it can only admit 2 electrons, so we write 1s2. But we need to have 8 electrons, so let's continue. In the case of S, we're finished here. There are no more letters, right? So now we continue with this one, S, and we are in 2, 2s, 2s, 2. So if we add 2 plus 2, we have 4, but we're still don't get to number 8. So we continue. In this case, we move to P, and is in the same row of 2, so we write 2p. And in the case of P, it can admit until 6 electrons, and you might say, Miss, but you add 4, not 6. Well, if I added 6, then 6 plus 2 is 8, plus 2 is 10, and I'm actually looking for 8. So I'm just going to add the ones that I need. So I'm going to stay with 4. Now if you count it, you have 2, 4, and 8. So this is the electronic configuration of oxygen. Electron dot diagrams. Elements in the same group have the same number of electrons in their outermost energy levels. An electron dot diagram uses the chemical symbol of an element, surrounded by dots to represent the number of electrons in the outermost energy level, as you can see in this chart. So, for example, hydrogen has only 1 and is represented with 1 dot. They are so significant that American chemist G.N. Lewis created a diagram to represent an element's outermost electrons while teaching a college chemistry class. Today we call this the Lewis diagram. Let's use the Lewis diagram to represent atoms and simple molecules. For example, how many valence electrons does chlorine have? First, look at the periodic table. And on top of it, write these imaginary numbers, 1, 2. Do not write any on the transition metals, and then continue here, 3, 4, 5, 6, 7, and 8. So this represents the number of valence electrons. The only exception would be helium, it has 2. Now let's look for chlorine. Did you find it? It's right here. So the answer is 7. Now with this, we can draw the Lewis dot diagram. As you can see, I use the, how is it represent the element, right? With Cl. I use the element symbol, and then I draw the dots. 1, 2, 3, 4, 5, 6, 7. Now, there is an order for drawing these dots. Imagine that around the element you have a square. On each square, you're going to draw only two dots. You can draw one or two, but not more than that, and try to do it in order. Now, let's practice drawing the Lewis diagram for the following elements: hydrogen, carbon, and oxygen. You can pause the video and draw them, and then you check your answers. So, ready? This would be hydrogen, carbon, and oxygen. Good job! Summary: Mendeleev organized elements based on atomic mass and chemical and physical properties. Moseley built upon Mendeleev's periodic table by further organizing elements by increasing atomic number. Elements in the same vertical column on the periodic table are known as a group. They share similar physical and chemical properties. Elements in the same horizontal row on the periodic table are known as period. They have the same number of energy levels.
I hope you found this video useful. Thanks for watching and until the next one. Bye!